An estuary is a partially enclosed body of water where fresh water from a river meets salt water from the ocean. You have both water and sediment from both of these sources mixing, creating ideal conditions for fish, wildlife, plants, and ecosystems in general. The Fraser River Estuary is the largest estuary in all of British Columbia. It plays a critical role in the life cycle of juvenile salmon. The Fraser River Delta is also a Ramsar wetland of international importance, and as such, it is a site of hemispheric significance for migratory shorebirds. The Fraser River Estuary is in dire need of our help because it has been extensively modified by human actions, human interventions for almost 200 years. We've constructed an extensive network of dikes throughout the estuary to protect our communities from flooding, but then that disconnects the river from its floodplain. We also conduct ongoing dredging where we remove sediment from the river and dispose it at sea, thus making less sediment available for ecosystems. And also we have a collection of river training structures that divert the course of the river to make it more favorable for navigation, but that also limits the access of fish to different foreshore ecosystems. Throughout all of these extensive changes, the amount of wetland habitat has dramatically decreased. So there's estimates that we've lost anywhere from about 70 to 90% of wetlands throughout the lower mainland. At Sturgeon Bank alone, since the 1980s, we've lost at least 160 hectares of tidal marsh habitat.
Raincoast and myself started studying juvenile salmon in the Fraser Estuary back in 2016, and we very quickly noticed that the Fraser Estuary was really disconnected with numerous structures that really interrupt the natural movement of these really small juvenile salmon that use the area. One of the things that we know about estuaries is they're really important transition zones for juvenile salmon. With these structures that we have in the estuary, juvenile fish are actually just pushed straight out into that full salt of the Strait of Georgia, likely before they're really ready. We decided that one of the most important activities in terms of restoration in the estuary was really starting to connect those different habitats that have been disconnected, allow fish to access those brackish water, that mixed water area that they really need to be able to transition to the full salt of the ocean. Today we're out on the North Arm jetty in the North Arm of the Fraser River, and we are here for the first day of construction of our connectivity restoration project. So over the next few weeks we're going to be creating an opening in this jetty that we're standing on right now to allow juvenile salmon and other fish to start to use the area a bit more naturally. So we're going to be able to reconnect the river with the sand and mud flats on the other side of the jetty here. Following the first breach, we did some monitoring for 2 seasons to see if it was effective. We found that lots of juvenile salmon were using the first breach, so we decided to move forward with the construction of the second breach. So we'll be monitoring both breaches for the next 2 years to look at fish passage as well as look at just general kind of fish use of the area with a real focus on juvenile salmon to make sure that our project is effective the way that we hope it is.
From about mid-March until early August, all of the juvenile salmon, they all travel downstream into the ocean, and certain species, such as juvenile ocean-type Chinook, spend a long time in the tidal marshes and tidal ecosystems of the Fraser Estuary. By adding sediment, we're trying to restore tidal marsh, which is of critical importance for these juvenile salmon that rely on these habitats as they're migrating from life in streams down into the oceans. Additionally, by adding sediment, we're trying to help these tidal ecosystems with sea level rise. Tidal marsh is important for a number of reasons beyond just the ecosystems and the benefits to fish and wildlife. Tidal marshes are also among the most productive ecosystems around, and they're incredibly effective at sequestering carbon. Tidal marshes also play a critical role in coastal flood protection because tidal marsh vegetation will slow water, reduce wave height, and and promote the buildup of sediments, thus adding to our coastal flood defenses. The Fraser Delta has been extensively modified, and that includes sediment delivery to these foreshore ecosystems has been limited. So by adding sediment, we're hoping to provide those critical nourishing materials that tidal marshes need to remain resilient and to thrive. After we've added the sediment, if you're standing on the dike at Richmond, you probably won't see that much. But there's a lot of work that goes into adding that sediment at Sturgeon Bank. We're actually having to float in this pipeline. It's over 1 kilometer long, and we will add it to the site, and then we're going to connect that pipeline to a dredge ship that will take sediments already being dredged from the Fraser River to support navigation. And instead of dumping that sediment into the Strait of Georgia, we're going to connect the dredge ship to that temporary sediment delivery pipeline and reuse those sediments. So we're going to pump a slurry of water and sediment through the pipeline onto Sturgeon Bank. This restoration project is a unique opportunity to test a very promising method to restore tidal marshes throughout the Fraser Delta. So we're here at Sturgeon Bank on the inaugural day of sediment addition for the Sturgeon Bank Sediment Enhancement Pilot Project. Really exciting. So probably in about the next 30-45 minutes, we're going to be pumping a slurry of sand and sediment onto Sturgeon Bank, trying to restore some tidal marsh. This is our second year in a row adding sediment at Sturgeon Bank. Last year, it was our very first time, and there were plenty of lessons learned. So this year, we're switching things up. We're using a new type of dredging, and we're dredging that sediment from a new area in the Fraser Estuary in order to collect those fine sediments, those silts that we really want, so that the waves and tides and currents can distribute that sediment to areas where it's needed most. Based on conversations with various rights holders and subject matter experts prior to beginning the project, we received input that we should probably target maybe 5 to 10 years of annual incremental sediment addition for this pilot project to really understand if this project is working. So we hope to be able to secure additional years of funding to continue it for that full duration of the pilot project.